So you undoubtedly will recall that we've talked before about FLApp, which is the flight listing case study. And I mentioned that there were a couple different variants of FLApp. And we talked before about kind of the client side of things, where you can use an Android client, or you could use some kind of web-based client to make requests onto the back-end servers or services. And the original version that we looked at, which is what we talked about the last couple of weeks, were the monolithic implementation and a client-based way on Android of accessing said monolithic implementation. And now we're going to start talking about the first of several FLApp versions that list airline flights and related information using Spring microservices. And these microservices, of course, can be configured to run in separate processes in some kind of distributed computing environment or a cluster computing environment, or whatever you want to use as your execution platform. You can see here that I kind of show at a high level what things look like. We have either an Android-based client or a web-based client that are accessing the services that are provided by FLApp, the microservices app variants. And there are two of them. We're going to take a look at the flights-microservices version tonight. And you can get that at the link at the bottom of the slide. Or you can also get access to the reactive microservices-based version, which we will not look at right away because that requires knowledge of more advanced features. So we'll probably start to take a look at that somewhat after we do the exam next week. So in this architecture, in the FLApp architecture, we have a particular component called Flight, which is a so-called front-end app gateway that uses the Eureka service discovery mechanisms to good effect. And you can basically think of this as kind of the front end, if you will, to a bunch of back-end microservices that actually implement the FLApp listing capabilities. Eureka is a very common service discovery mechanism that is used to find and communicate with back-end microservices. It's used by a so-called app gateway, in this case, the flight component. And the flight component uses Eureka to find and communicate with back-end microservices without having to hard code ports or hosts or host names, maybe a better way to put it. So we don't have to know anything about the ports and the host names. We just have to know how to contact the flights microservice and everything else, or flights app gateway. And then everything else is handled by what we refer to here as server-side discovery. So it's actually the server that discovers the microservices it needs to do its job. Now, the way this works, as you'll see here shortly, is we have each backend microservice, and we'll talk about them. We have a number of them in this example, and you could imagine many more in a real production system. Each of these backend microservices is going to register with a service registry. And this is a very common pattern you see a lot in microservices-based architectures where you've got a service registry of some kind. In this particular case, we have a service registry and the various microservices that are under control of the overall FLApp app, the FLApp app. They will register themselves, and then clients can come along and then they talk to the app gateway and it discovers the various services. Now, what's interesting about this is registration is largely performed declaratively. So you may remember from either earlier classes or your own knowledge you've gotten from work or study or whatnot, that declarative programming is a paradigm for developing software that focuses on what computations should be performed rather than on how they should be performed or how they should be computed. So the point is what they do, not how they do it. And I like to use this iceberg metaphor when I talk about declarative programming because I think it does a good job of showing the rationale. You want to focus on the what, which is ideally more limited than the how, which is bigger. Now, in the context of Spring and Eureka and the FLApp case study, this registration is performed using two things. One are annotations. So there are various annotations that are applied in the code. And here's just a little teeny snippet of something we'll take a look at in more detail later. This is the airport application. And you can see that the airport application is going to have this enable discovery client annotation on the airport application. And it also has this thing called property sources. And that basically tells the runtime where to find the various properties that correspond to this particular microservice. And we'll take a much more detailed look at this here shortly. So that's part of how registration is performed declaratively. You mark the server or the application using these mechanisms, and then it can be part of the discovery process. And then there's also these things called property files. And there's a bunch of different property files. Here's kind of the common property file. You can see that that's actually what's referenced over here with Eureka client properties. That actually points to this particular file. And this is what's used for the different discovery services. They're all kind of common in that respect. And so they don't have a port number. They're going to be given a port number. So they start with a port number of 0. And all they really do is they basically say where the Eureka service is going to reside. What port will it be on? In this particular case, it's on the local host because I'm running everything on my computer. But you can imagine in a bigger environment, that would be handled via some other means in a load balanced or cluster-like environment, which is more than I want to show tonight. But without loss of generality, this is basically how things work. And then we set a bunch of different flags here in the properties file to enable the Eureka discovery service, to basically have the client register itself with the Eureka and do various other things to configure and provision the use of the Eureka discovery service properly by each of the microservices. Now, the flight app gateway can then locate the microservices that have been registered with Eureka by name. And we'll take a closer look at how all this works, but here's just a little snippet of it from the code we'll take a look at later. There's a discovery client that you can basically auto wire into your programs when you use Eureka. And discovery client says, get me the services, all the services that have been registered with it. And as you can see here, what happens is we get the list of services, we turn those lists into a stream of services, and then we basically only allow ones that match the airline string. And we'll see how that works later. But services can name themselves when they're registered. And in this case, we might look for airline services, and we collect those things as a list and return them. So that's a way that a program can discover what services it actually needs to know about and care about. Now, that's kind of getting things bootstrapped on the server side and getting the app gateway to know where to find the various services that are microservices that are registered in its purview. But then there's also the way in which we access those services. Now, keep in mind, everything I'm talking about here is in the context of the app gateway. So it's already in the back end. It's just the front end to the back end, if you understand what that means. Now, of course, we could also use these things if we were really clients in a normal client sense. But what I'm talking about here is using this from the app gateway perspective to make calls on the microservices. And there's two general ways to do that. One way is to use something called a REST template. And this has historically been used for so-called synchronous calls. So here's an example where we're going to have the FLApp flight component, the app gateway service, make a call to the airport's microservice to get a list of all the airports that it knows about. And you can see here, this is how we do that. You make a REST template using auto wiring. We'll look at that in more detail in a second. We then go ahead and make a call to the get4entity method on the REST template class, and we give it the URL we want it to communicate with, to send a GET request to, and then we also tell it what we want the responses to be. So it's going to come back as an array of airports. And then we convert that into a response body and do some other stuff to it. So we end up with an array of airports. The way this works under the hood is it uses Eureka to redirect the HTTP request to the registered airport microservice. So this whole thing, of course, assumes that we've already registered the airport microservice by some combination of annotations and some kind of combination of property files, and we've got things up and running and so on and so forth. And so when this call is made, we don't have to put in the actual name or port. Sorry, we just put the name. We don't put the port number or the name of the host itself. That's figured out by Eureka using the magic of the get for entity method on the REST template class. And you can also enable load balancing. So we don't do that in this particular case, but if you had a bunch of different implementations for scalability purposes, then you could tell the Spring REST template to automatically do load balancing with some kind of perhaps round robin like mechanism or whatever mechanism that was configured for use. So that's how synchronous calls are done through REST template. Asynchronous calls, which we'll talk about in much more detail later when we get into WebFlux and reactive programming with the project reactor reactive types, it uses a different class called web client to perform async calls. And you can see here that it's somewhat similar. You say to the web client, I want to make a GET request. This is kind of a fluent interface-like approach. And here's the URI I want you to contact with this URL. Then you call retrieve. That starts the two-way call in motion. And then what you get back will be JSON that's converted into a flux to an airport. So a flux is kind of like an asynchronous list. So we'll basically have a asynchronous list or a flux of airport objects that come back. So this particular approach is asynchronous as opposed to synchronous, which is what REST template does, and we'll talk about it more later. Just very quickly, you can also use Eureka and load balancing for web client, just like you can use Eureka and load balancing for REST template. So they both work the same sort of way in the context of Spring. So that kind of gives you a high-level overview of what we're going to show here when we look at the code in more detail. Before we do that, though, let's kind of give a bird's eye view of what we're going to look at when we get into the code. So we have a bunch of back-end microservices, and they do kind of obvious things. They return a list of all the known airports. And right now that's implemented as a database in accordance with the Java Persistence API or the Java Persistence Architecture, JPA. We could do it other ways, but that's how we do it here. That actually is very similar to what we had with the monolithic version. We also have something that will return the current exchange rates for different pairs of currencies. And again, that's currently stored as a JPA database, but should probably be implemented as a separate microservice. In other words, we want to basically pull from some real full-fledged currency service. And if you take a look at the link at the bottom of the slide, you can find out more information about how you might write one of those kind of things. And then the final microservice, and we actually have multiple of them, multiple instances of them, is an airline microservice that returns flight information for various airlines. So we'll have different microservices for American Airlines and Southwest Airlines and United Airlines and British Airlines or British Airways or Air France or whatever. That's also currently stored in a JPA database, but in real life, those would undoubtedly be implemented by the airlines themselves, and then they would provide various partner services like Expedia or Travelocity or Priceline or whatever, access to the APIs for querying their most likely REST-based databases that provide flight information and pricing and so on and so forth. Now, the implementation we're going to look at here in just a second uses functional programming, and it's based on synchronous two-way calls. So it's going to use essentially the web MVC model of Spring, and it'll use the modern Java functional programming, parallel programming framework, Java parallel streams. So we show the implementations with parallel streams. Of course, we could use other frameworks here too, but this is the one I chose because it's convenient and really easy to do, and will hopefully build upon things you've learned in previous courses here in the program. I should also mention that this is just the current version. We will look at a much cooler version later, but this is cool enough for now, and it'll certainly be enough to demonstrate the concept of microservices in the context of Spring WebMVC. So that's the end of the overview of this variant of the FLApp case study. But as I mentioned before, we'll look at other ones later.